So you see problem 4, force acceleration 1, and the drum having a radius of 5 feet, and the weight is 161 pounds, and the radius of gyration with respect to the axis perpendicular to the paper and through the center of mass G. So basically that is kg equal to 2 feet, and a couple with magnitude, so we have a couple moment 400 foot-pounds applied. Determine the acceleration of the center of mass G, and also determine the magnitude and direction of the friction force. And they also give us the mu sub s 0.3 and mu sub k 0.2. So it's always the first thing first, classify motion. And this is a drum and only one body, and it translates going down to the incline, and it also rotates clockwise, so it will be a GPM motion, GPM, general plane motion. And the second step, we find out the properties. So they give us the weight equal to 161 pound. So from that we can find out the mass equal to 161 divided by 32.2 equal to 5 slugs. 5 slugs. And then they also give us the kg equal to 2 feet. So we also find out the mass moment of inertia about the center of mass for the axis go through G perpendicular to the drum. So we have that the m kg square equal to 5 times 2 square. So we have Ig equal to 20 slug feet square. So that what is the properties. And then the next is draw the diagram. And in this case, we have a free body diagram equal to kinetic diagram. We only have one body, so we draw two, for one for free body diagram and the other for kinetic diagram. And this body on the inclined surface, so you have to draw that on the inclined surface. So the drum, the same drum there, where the center of mass also at the center. So we have G, you have G. The left side, free body diagram, the first one, you see the weight, 161 pounds. We have the normal force perpendicular to the surface at the point of contact, that the N. Then the surface, inclined surface 435, and you see 435. We also have friction, assume we don't know, so you can assume friction going down. And because it's inclined surface, so you can assume the axis is parallel and perpendicular, and perpendicular. And then they also have a couple 400 foot-pounds clockwise, so that all the force moment couple on the free body diagram. So show it here, not on the kinetic diagram. Keep that in mind. So you have C equal to 400 foot-pound. Make it clearer. Foot-pound in there, and that all for the free body diagram. And then we go to kinetic diagram. So balance wheel, balance drum on the inclined surface, so parallel and perpendicular, we have it M A G parallel, so that is M we find out is 5, so it will be 5 AG parallel. MAG perpendicular, G parallel to the inclined surface, not jump up and down in the perpendicular axis, so you don't have MAG perpendicular axis. So, and then the wheel, the drum also rotate clockwise, so you also have IG alpha, and in this case it equal to 20 alpha. And that is the diagrams we have, and then we can write the equation, scalar equation. So here we have 3 equations. Let's write down sum of all the force in x, not x direction, in a parallel direction, assume going down is positive, so you will have equal to MAG parallel. So from that we can have all the force in x, so you can have it 161, and this is a slope triangle 3, 4, 5, so it will be 3 feet 161, and then we plus F, and then normal force is 0 in here. So, and couple is not in the x or y or parallel perpendicular force. So on the left side you will have MAG parallel, in this case 5 AG parallel, and that we call that equation 1. And then we can have sum of all the force in perpendicular distance, and then we perpendicular axis, assume that is positive, MAG perpendicular. From that we can have normal force, so normal force, and then the weight 4 feet, and it's going down, so negative 4 feet 161 equal to MAG perpendicular. Look at the kinetic diagrams. We have nothing because G not jump up and down in the perpendicular axis, so you have it 0. And from here, that is equation 2. But that equation 2 we can find out one equation, one unknowns, we can find out and equal to 128.8 pounds. So that is the normal force. And then we also have a moment. Let's take a moment about the center of mass. Of course, you can take any other point. For example, you can take at the point of contact PC, that I will show you a little bit later. But that, for now, we take moment about G, and because that the drum rotate clockwise, so let's assume clockwise positive equal to IG alpha. So from that, what do we have? The weight go through G, 0. Normal force go through G, 0. Couple involved clockwise, so same, positive 400. Friction force about G, counterclockwise, so negative 5 feet, because the radius of the drum is 5 feet. 5 feet. So from that we can have that it will be the time FF equal to IG alpha. In this case it's 20 alpha. That is the equation 3. So let's see, what do you have? We have 3 equations. How many unknowns? 1, 2, 3. Of course we already find out n, but if we count 3 equations, then we count unknown n, and then 4. So as you can see, you have 4 unknowns and 3 equation. So when you have that, you have to draw another free body diagram equal to kinetic diagram, but unfortunately this this problem only have one rigid body, which is drum. So what do? When it not enough equation, you have to keep in mind, assume something. Assume something. So when you assume something, in this case, you assume no slip wheel, and it always assume no slip wheels. Don't assume slipping wheel first. Always assume no slip wheel, so that you have to something to check. Keep that in mind. So let's assume no slip wheel. When it no slip wheel, what do you have? Remember, we talk about acceleration. We also have V equal to omega r. But in this case, talk about the acceleration. So we use properly. We don't want to introduce another unknown. We only want to find out the relationship between the unknowns 1, 2, 3, 4 in the first three equations we have. So here is about acceleration. So as you can see, because the G is the center, it will be equal to alpha r for no slip wheel. So what do you have here is the acceleration at G, in this case, parallel axis equal to alpha r. R in this case is 5, so it will be 5 alpha. So let's call that is equation 4. And then we can plug that equation 4 to number 1 and then combine with equation number 3 so you can solve for this problem. So let's plug number 4 to number 1, then we have equation 1 and we have equation 3 become what? So let's write down. You see, number 1 equal to 3/5 161 plus F equal to 5 alpha for A G parallel, and then you have number 3. You will have 400 minus 5 FF equal to 20 alpha, and with that we can solve for these two equations, two unknowns. We can find out alpha equal to 6.09 radian per second square clockwise, and we also find out the friction force equal to 55.4 pounds. What's going on? 55.4 pounds. So that's what you have, and because you assume something, you have to check that assumption. So you have to check assumption, check no slip wheel assumption. No slip wheel assumption, and in that case, as you can see, have to be FF have to greater than mu sub Sn. Let's see whether that's the case. So FF equal to 55.4 pounds mu sub Sn equal to 0.3 times, and we have it here 128.8. So 128.8, which is equal to 38.6 pounds. And as you can see, with that we have that one FF that we find out. Based on what we assume, no slip wheel greater than mu sub Sn is supposed to be less than. So as you can see, not okay. That one is not okay. So what does that mean? No slip wheel assumption not good. Okay. So what does that mean? No slip assumption not good. So what does that mean? You have, we assume no slip and not good, then it has to be slip. Drum slip. When drum slip, what do we have? What do we have for drum slip? We will have FF equal to mu sub K. Therefore, we have FF equal to mu sub K and mu sub K equal to 0.2 and equal to 128.8. So you will have that is the 25.8 pounds. And for the wheel or the drum is slipping, the direction of the friction is opposed to the motion at the point of contact. So as you can see, for the wheel it clockwise, at the point of contact, the motion it will be go up to the inclined surface. Friction has to be going down. So that with that we will have the direction, it will be going down, and the slope triangle here 4, 3, 5 for slope triangle, and that is the answer. That is the answer. Okay, you may see. Okay, so what is the acceleration? By the way, the angular acceleration for yes. So you can plug into equation 3 to find out the angular acceleration. Angular acceleration of this one. Plug to that, you can have 400 minus 3 FF. In that case, the FF here equal to 25.8 pounds equal to 20 alpha. From that, we can have alpha equal to 13.55 radian per second square clockwise. So that what you have for the alpha. If you want to see the HE parallels, so as you can see, you can plug to equation 1. So you have equation 1, 3/5, 161 plus FF. So it will be 25.8 equal to 5 HE parallel. Don't plug to 5 alpha in here. So from that you can have HE parallel equal to, let's see what that equal to. So 0.6 times 161 plus 25.8 divided by 5, it equal to 24.5 feet per second square and going down 435. And as you can see, they are not the same. They are not the same because slipping, as you can see, HE parallel equal to 24.5 feet per second square. It's not the same as alpha R, which is 1355 times 5. This is what we have here. 1355 times 5 equal to 67.8. So with that, because no slip, so you see the HE parallel is not the same as alpha R for no slip wheel. So let me conclude. in this problem, as you can see, key point, write equation, draw diagram. If too many unknowns, assume something. Always assume no slip wheel first. When you assume, you have to check your assumption whether it's good or not. In this case, not good. So when it's not good, you have ff equal to mu sub k, and when the wheel is slip. And then you can go ahead to find out the acceleration part of these problems. And by the way, we also take moment about G, but you can take, like I say at the beginning, you can take moment at the point of contact. And in the PDF solution, we show that, so it in here, as you can see, the moment, if you take the point other than the point of contact, the term in the kinetic diagram, you see Ig alpha, you see Ig alpha, and this is, as you can see, that actually it MAG parallel and time the radius, so that you have that what you have it in that components. And with that, we can continue to solve with, if you take moment about the point of contact PC, or in this case POC. The process will be the same, but as you can see, the right part of the moment equation is more complicated than the one if we only take moment about G, which is only Ig alpha, 20 alpha in this case. With that, we conclude for problem 4 and also conclude for force acceleration 1.